My name is Erik Skultety. I work for Red Hat for the virtualization team as a LIBVIRT developer, and today I'd like to talk about LIBVIRT administration API, which we recently enabled within our LIBVIRT daemon. Before diving into the interface and its functionality, and I would like to talk about the daemon for a few words about its internals and how we actually enable the admin within it. But for the last few weeks, I have a bit of a hard time to find out what would be the proper introduction to my presentation, because I was continuously being discouraged by my coworkers not to start my presentation about what LIBVIRT is. Everyone knows what LIBVIRT is, right? And so where is it? Now I would like to ask you about it. So any volunteers? No, come on, cooperate a bit. So it's a toolset, a virtualization toolset that allows us to utilize the virtualization capabilities of the underlying hypervisor. And it consists of a C library with some bindings for different kinds of languages. It does consist of a daemon, which acts as a backend for the library, implementing most of the functionality. And then we have a command line interface called virt, which acts as a front end to expose all the functionality to connect to the daemon, which it's also a scriptable tool. And the advantage of using virt is that if you want to just play with LIBVIRT a bit, you don't really have to write your own application, right? It does link to LIBVIRT, so it's a functionality preview. Now, I'm pretty sure you've already seen a picture like this. What LIBVIRT is that it works as a glue between the management layer and the virtualization layer, except for the virt manga there. So it should be obviously virt manager. So to put it a bit technical, in one sentence, that LIBVIRT does provide, it creates an abstract middleware layer that provides you a stable, and this is the most important thing, a uniform and also portable to the extent of the operating system support interface for your applications to dealing with the underlying hypervisor specifics and inconsistencies. And I say inconsistencies because some of the hypervisors actually do tend to break their backwards compatibility, their API constantly. So it's a nice thing if you just do not have to deal about it in your application, right? And besides that, so it does provide a stable interface, right? So you can manage not just virtual machines, but also we do provide some means to manage virtual networks and also support different kinds of storage solutions. Now to the daemon, I mentioned that we do have a backend 2 slides ago. So if you do not have any previous experience with LIBVIRT, you might ask a question: why do we actually need the daemon? Why not just hard code it why not just use LIBVIRT as a translation layer providing the uniform interface and translate it to all those different kinds of different and hypervisor specific interfaces? The main reason is that some of the virtualization solutions actually do not provide any means for there is no way how to manage it remotely. You can only do it locally, which is not really convenient, is it? So LIBVIRT-D then provides the tunnel. It creates means it creates the remote management, the remote tunnel, and you can use to communicate with all the local virtualization solutions. A second one would be that it stores the VM state, and it tracks all the specifics, all the devices that you actually hot plugged into the VM without the need to poll every time and ask the hypervisor about the domain. It knows it. So that will be it. Now, so we know that it can manage virtual machines, storage solutions, and virtual networks. How about managing itself? Can it manage itself? Well, now it can. But originally, the only way how to configure it was via its configuration file, which is libvirt-conf. But that provided us only with persistent configuration, which means that there was no way how to change it during runtime. And the second thing, restart was needed every time you change the configuration, which can be inconvenient. But is the restart bad? Well, it isn't. The restart takes, in the worst case scenario, only a few seconds, usually few milliseconds. And I recall there was some speed up since the last KVM forum. So usually it doesn't pose a problem. And all of the jobs are asynchronous. So usually you can recover all the jobs, and no problem with that. It's just inconvenient, because if you restart the daemon, it automatically kills all the existing connections to all its clients. And let's say there is my ongoing migration over several tens, maybe 100 gigs. In that case, imagine you restart a daemon, an admin restarts daemon. Well, the person that issued the ongoing migration would be really happy about it, would they? Because it takes time. So it's a matter of convenience. Also, restarting the daemon means that you lose the current session, which might be interesting. We want the current session, and I'll get to the point why we need it. So now to the admin itself. Where is it? It's a new and completely separate set of APIs that are shipped within a new standalone library, separate library, LIBVIRT-ADMIN. And why did we why did we do this? Why did we incorporate it in a new library instead of doing it into the existing library? Well, we thought that it's much more self-contained, and we want it to be separate, and also it's much more self-contained, and which is good for maintainability reasons. And also, within the package, we also ship virt-admin binary, which is based on the virt client. So if you're familiar with the virt client, it works pretty much the same, just different commands. Why should you be interested in it? Now, I said that you can configure the daemon during runtime, but it also provides us with some monitoring. We had a customer case for this. So it would be nice to provide some means to do some monitoring, threadpool monitoring, how many, to know about the amount of current active workers within the threadpool. And also do some client monitoring. So we would like to know about the clients that are connected to us, wouldn't we? When did they connect, or from where they did connect. So that's about it. What it can do right now to be more specific. So it does live reconfiguration of logging parameters like logging level, if it's debug, error, warning, or info. It does some threadpool management, so you can fiddle a bit with the amounts of workers that are active in the threadpool, and also some client management. Yeah, I already said that, which is listing. You can get some details out of it, and you can also disconnect a client in a forceful manner if you decide so. And and there are some limits to. We do use client limits in the configuration file. So let's say in the configuration file says you can only allow 120 clients. So why do we have actually such a limit? If it didn't, there would be a high possibility of making a DOS attack, of depleting all the resources we have if we allowed it's hardware limited, let's say infinite number of client connections. So now we're getting a bit more into the detail for each of the parts I talked about on this slide. So to the thread pool management, imagine you have a virtual server. And as it happens, servers do tend to fall for load. So there is this server load, which causes that all of the workers, for the amount of requests that comes to the server, that all of the worker threads that you have working on the server are just occupied with all the requests. So in that case, any other request to come would block, which causes delay in service delivery. And that delay may vary. So first, that means you either, what can you do about it if you have a server load? If you are utilized to your full potential, there's really nothing you can do. If you're not, or if it's a virtual server, you can hot plug more resources. In that case, you could actually make use of those resources by spawning more worker threads within the daemon. In that case, we should identify which of the daemon servers is hitting the limit. Now, what is a server? Shouldn't the daemon act as a server in the client-server communication model? It should. So let's talk about the daemon internals for a bit to fully understand what is a server actually. Well, before that, when talking about LIBVIRT internals, usually you will see a picture kind of like this. There is an application that connects and they would like to connect or execute some action on the daemon on some hypervisor. So it connects using the API, so it invokes the public API, which translates to the driver-specific API, then goes to the driver implementation, and through the RPC comes to the daemon itself, which issues the same public API, translates to a different, and now is really specific hypervisor driver and executes the action. But we do treat the daemon as a black box. We usually do not talk about its internals. So underneath, what you find, this is the server. Just take the daemon as an entity, as an object. So within the daemon, there is a server, and it's called LIBVIRT-ADMIN. Yeah, might be a bit confusing, but why we did this is, if we go back, usually what we tell is that you connect directly to the hypervisor. Well, you connect to the daemon, which provides the tunnel. So it's completely transparent. So we did name the server LIBVIRT-ADMIN just because we wanted to express that usually you connected to this server instead of the daemon itself or the hypervisor as you might have thought. So this is the original server. It does have a thread pool in it, and it is responsible for accepting all the client connections. Now, to accept the client connections, it does comprise of several sub-entities we call service. And there is two kinds of services we actually provide. First of all, are Unix services that do create a Unix socket you can connect to. And so are two types of them, read-write and read-only Unix socket. And then there are, two or three services actually. So there is a TCP service which works on top of a classic TCP IP socket. And there is, but this one is unencrypted and shouldn't be used in production. And also there is the TLS service, which does provide an encrypted connection. So now when a request comes to the service within the service, the request will be passed because it's in XDR, so will be deserialized, but only the header will be deserialized. And according to the header, a job will be created, put into a job queue, and inserted into the threadpool. So the first worker that is free would take it out of the job queue, and then would deserialize the message payload, the rest of it, to know the procedure arguments, and then it would issue, as I said, the public API, which would translate to some kind of driver, which is in a driver table. Now, one solution to the admin, how to enable admin within the daemon, would be to put it as a driver into the driver table. But in that case, it will be pretty general, as we wanted to it be separate. In that, if we put it into the driver table, virt could actually connect to it. And that wasn't what we wanted to, because virt couldn't know what to do with it. So what we actually did to separate completely, and I hope it's much more self-contained, was that we created a new server, which our modular architecture allowed us to do. We created a completely new server called admin, which for now employs only one kind of service. It's a unique service, and you can only connect to the admin server through a root-only socket. And that is because if you wanted to touch the libvirt config, actually, you had to have root permissions. So in that case, it makes kind of sense to allow only a root to connect to the socket. So this is just what I said in text form. Now back to the threadpool management. So we know what kind of servers do we have, and we would like to know which of the servers is hitting on the limits. So we could fiddle with the limits and spawn more or less, or kill some workers. I do have a small demo, so maybe I will manage to maybe not. Can you see it? Not anymore. Oh. All right. Let's do it some other way, because I'm slowly running out of time. Let's do the demo at the end of the presentation. So when you will issue the command server threadpool info to get the limits on the workers, and then you would you would actually change the limits for the workers, and you would spawn more, or you would kill some of the existing threadpool workers. Now to the client management. As I said, you would like to know how many client connections are there. So you would you would be able to make some statistics, and you could fiddle with the limits on the client, so that would be more tailored to your use case. Now, for that, you will issue this command. What is much more interesting about the clients than this is we expect that there will be some third-party applications that will be interested into implementing some policy enforcement, which LIBVIRT won't do. So in that case, if you want to implement some policy enforcement on the existing connections, you need to know all the details about the client, like which IP it connected from, what is the timestamp, did it use an authentication, did it use a read-only connection. So we would like to list all the connections and provide the detail for it. So these are the commands, and hopefully I will still make it at the end of the presentations. Now logging, this is actually the only bit that still haven't been pushed to upstream. It's on the review process. Now, everyone knows why we do have logging. But it happens that when customers do have problems, they usually do not have, well, usually it happens that they do not have debugging enabled. So they have to enable their debugging and set the level of the debug appropriately. Well, the problem is it requires daemon restart, as I said. You can, most of the times, you can repeat the command to actually, when there is a failure, you can repeat the command and the error will reoccur. No problem. But it happened, there are some anomalies, in which case you would like to, really would like to inspect the current state of the domain. So in that case, you have to do it runtime. And that is the main reason why we want to do that. We want to inspect the current session, not restart the daemon. So if you just enable the logging, there will be plenty of logs. And the only thing you can find, yeah, you use grep and you see there is an error. But there is loads of logs because some modules are really verbose without adding no information at all. So if you do not provide any filtering, so you are looking for the culprit, you're looking, and then you find something like this. You're happy because you found the culprit. But LIBVIRT provides a filtering method. Yes, it did, and we would like to do it on the fly. Now, to the filtering. Why do we actually have filtering? LD provides some sort of filtering, but if I understood it correctly, it only does some rate limiting. It doesn't provide any regular expression filtering. In that case, you cannot know. You don't know our internals. In that case, it would be better if you used our filtering on top, before applying your own filtering, using another filtering system like LD. So I already mentioned, and we can change the logging level from debug info, but debug will be most of the time the thing you want. So we want to provide a custom set of filters to bring the filtering to a whole another level, to clear the logging files a bit, and also if you want to add just more filtering output, you define a new set of logging outputs. To the future improvements, we would like to implement some client discover events. So as I was talking about the third-party applications that would implement the policy enforcement, if they decided that they disconnect the client, in that case, if the client reconnects, which usually they will try to because they will implement just the loop, they found out that they were disconnected, so they just reconnect automatically. So we would like to provide send an event that would be registered by these third-party applications that it would tell them, hey, there is a client trying to connect. Do with it. We know these and these information about it. So do with it what you want. Then, yeah, I told you that we currently only support connecting through the root-only Unix socket, and that's because we were a bit we employ a bit of a defending approach when thinking about it, and that means that we didn't want to rely on the SSH. There might be a bug in the SSH that will lead to root privilege elevation, and in that case you could just use the privilege elevation to disconnect all the clients, set it to 0, and that will create DOS attack. And also that comes with that applies to the threadpool as well. So in the future we might decide to support remote access. We'll see about that. I would like to encourage you on some debate on the upstream about that. And also to improve the experience for the third-party applications, they're implementing the policy enforcement, it would be also nice to log the clients, because the clients are anonymous, so we could log some activity and they would improve their policy decisions. Lastly, if you would like to reach us, you can contact us on our mailing list, depending if you want help from users' point of view on LIBVIRT users, or you have developer message that would like to send us. So you can, if you want to post patches, you can post it in here. Make sure you look on our contributor guidelines on libvirt.org, or you can find us on the IRC. Now, yeah, before questions, since this is the last presentation, I have still 5 minutes left. I'll try to fix the terminal. And it might work, it might not work. Yep. Oh. So. To the threadpool management. So in that case, if you inspect the LIBVIRT-D server, right now it's the default configuration. It's the limits are minimum workers is 5 and max workers 20, and currently there is 5 workers, 5 free. There's nothing to go on, and there is nothing in the queue. To simulate the load, I would probably, the best way to do it would be to set the I really cannot see that. Like this? Yes. Threadpool set which server? It's min workers. Yeah. Will live there? Maybe. Yeah, great. So let's look at it now. Yeah. In that case, if you try to connect or do something useful with it, like listing domains, yeah. Wait, what? But that doesn't matter if it already connected. Since I do not have any workers left, it should just, maybe it's cached. It probably will be cached. Let's start a domain.
You still have 5 priority workers.
Yeah, okay, listing is priority. Maybe, what could be the issue? Maybe if we do DOM info. Yeah. So the first information that we got, it was cached. The info that is getting from the server is hanging because there are no workers left to do it. If we reset the workers like to 5 and spawn more with like 2, so we do have now 2 workers and the job finished. The same we go with client. I would like to show you the disconnect. So I now have one TCP client connected. Let's get some info out of it. That reminds me that we should really implement the feature that the server will be automatically filled out. So we know that the client does have ID 1, connection time. We know the transport layer. We know that read-only, it doesn't use read-only connection. It did use, because I was already connected, it did use some authentication, and the authentication name for SASL was test. We also know that it was its IP address, which was localhost, which is not that hard. We can now client disconnect. Sorry. Now, and they reconnect it, but oh.
You run the disconnection.
Yeah, I see. Yep. Sure. Thank you. I always knew there will be some fair chance of a malfunction, maybe seg fault. So. Yeah, I've run out of time. I'm sorry, I couldn't make more out of the demo. So yeah, I could put the slides again, but it doesn't matter. So any questions for my presentation?
Not a question, just a bit tiny remark. We already discussed that. The commands,
yep.
they will be named slightly differently pretty soon because there is a weird disconnect between SRV versus client as a prefix. That will change, and it will be very beautiful.
Yeah, there is a bit of a, it is a bit weird, the naming. Yeah, there was a big problem with the naming. Yeah, it's always a problem when you try to make up some new and nice names for the commands. Yeah, we can provide some aliases for it, definitely.
It's going to be better.
Yep, sure.
We're out of time. Thank you very much. I'd like to ask everybody to please move over to the other conference for the final photo. Thank you.